of what you see in the wild-type context. Now, in the MSX mutants and in the GLE3 together with Sony-Kitchuk absence, you have an increase of the SAL4 expression. In the MSX mutant context, along with the absence of Sony-Kitchuk, the increase is not as much as that in the wild type, but is much higher than what you see in the Sony-Kitchuk null context. And this is then higher when you look at the GLE3 heterozygous mutant as well. But what is interesting is that in the combined mutation, or the quadruple mutation, of Sony-Kitchuk null mutation, along with the triple GLE3, MSX1, and MSX2 mutants, you have a much higher expression of SAL4, and also it's starting to be expressed anteriorly. So this is even more higher than what you see in the wild-type context, which shows indeed that these MSX and GLE are regulating common targets during anterior limb morphogenesis. There are also other targets of interest that we came up with, such as ZIG2. ZIG2 is a transcription factor, and it's been known to be a direct target of GLE3 as well. And you can see indeed that it has been upregulated in the mutant context, in the anterior part of the limb, and also in the hind limbs as well. And it's similarly enhanced in the GLE3 null context as well. So ZIG2 serves as a common target between MSX and GLE3 mutants. And indeed, other targets such as TFAP2C was also known to be regulated similarly, such as in the MSX1 and 2 mutant, you have an anterior upregulation of TFAP2C in forelimbs and in the hind limbs, and also in the GLE3 null mutant as well, where it's also expressed, especially in the hind limbs. So with these, we know there are common targets shared between MSX and GLE3, and they're regulating them together. But also, we had one more result which showed a synergy that was also present. Now, CDK6 is a kinase and it's involved in cell proliferation. In a normal context, in developing limbs, CDK6 is not expressed anteriorly. However, in the absence of GLE3 heterozygous, you have a slight upregulation anteriorly of CDK6. But this is not even absent and not even present in the MSX1 to double mutant. The most striking part is that when you combine these mutations of MSX1, 2, and GLE3, you have now an enhanced, beautiful atopic anterior expansion of CDK6. Now, CDK6, as I mentioned, is implied in proliferation, and GLE3 and MSX null mutants have a depletion of apoptosis as well. So all of these then lead to the polydiploid could